Alright guys, in this video we are going to learn how to classify 2D figures. This is a lesson that we will not be teaching in class, so it is really important that you are super focused and attentive right now because this is a topic that you need to be familiar with. And so make sure that you have your notebook open to a fresh page with the date and right on the very top classifying 2D figures. Your teacher will be checking to make sure that you have responded to all the things that I ask you to as you go through this video. You are going to need a good chunk of time, so make sure that you are in a comfortable place, free from distraction, and let's see what we can do. So this is a geometry topic. It does have to do with shapes, but first I just want to see what you know about classifying objects in general. So we're going to be classifying 2D figures, and we'll get to what that means in just a minute. But let's first talk about what it means to classify. So a lot of times, especially in reading or in spelling, you've done word sorts before and you've sorted things into categories. So classification has to do with sorting things into categories. So if you look at these pictures that I have here, there are a lot of different ways that I could classify or categorize these things. I could separate them if I wanted to into fruits and vegetables. I could put the apple with the orange and the banana, and I could say that the squash, the carrot, and the pepper are vegetables. So the red circles are fruits and the green circles are vegetables. I could also sort them differently if I wanted. I could sort them by color. I could say the apple and the pepper are red, the orange and the carrot are orange, and the banana and the squash are yellow. I could also classify them by shape. I could talk about which ones are long versus which ones are kind of roundish. There's a lot of different ways that I could choose to do this. So classification does not only have to be one way. So we can actually classify shapes as well. And the way that we classify shapes is we pay attention to their number of sides. We look at their number of angles. And sometimes we look at the types of lines that are used as sides. And sometimes we look at the type of angles that are given. And we will talk about those different things, but different from the fruits and vegetables, which we could group into so many different categories. Shapes are really just sort of specific to looking at their sides, their angles, and the types of sides and angles that we have. So first, just a quick review of vocabulary, and you should have seen this already in Ms. Johnson's video, but when you have a 2D figure, which means that it is two-dimensional, it has the dimensions of length and width. Those are the two dimensions. There are always sides involved, which are the lines or line segments that are used to come together to form the figure. They, of course, when two sides or when two lines or line segments meet up, they meet at a point, and we call that point the vertex. And then, of course, as you learned in Ms. Johnson's video, when two lines or line segments come together at a vertex, they create what we call an angle. And we use a different measurement tool to measure angles. We wouldn't use a ruler because rulers measure length. We wouldn't use a scale because scales measure weight. And we certainly wouldn't use any measuring cups or things like that. We need something different because when we're trying to figure out how long an angle is, what we're really thinking about is if this whole thing were in a circle and we figured out that this was the center of the circle, how many degrees, because we measure openings of angles with degrees, would be inside of here. Like how far does it open? And so we use something called degrees to measure that, like you learned with Ms. Johnson. And we use protractors, which are a special tool to measure that. So what kinds of shapes are we going to be classifying in 4th grade? We are going to classify polygons. So polygons are special 2D figures. If you think about it like an umbrella, you've got 2D figures, and below 2D figures are all kinds of shapes, and polygons are one type of 2D shape. And actually, there are specific types of polygons, as you can see here. There are triangles, like you see right here. There are pentagons. There are quadrilaterals. There are hexagons. There are octagons. These are all types of polygons, and a polygon is a type of 2D figure. So all of these that I'm circling in red would actually fit under an additional umbrella of polygon, and 2D figures are the biggest. So what are polygons? Polygons have to be closed, plane figures made up of line segments. So what does that mean? Closed means that the figure comes together and closes up. So like when I draw this angle right here, it's not closed until I draw this final line segment from here to here, creating a triangle, which is a polygon. Because it's closed, it's a plane figure, which means that it's 2D. That's all that means, that it like lives in a plane, a flat plane. And then line segments, of course, are the lines or sides that are used to make the figure up. So as long as it fits those different qualities, we can call it a polygon. In your notebook, press pause, and I want you to please write down what a polygon is and what a 2D figure is. Go ahead. Okay, so now identify open and closed plane figures. I just want to make sure that you understand what an open and closed plane figure is. These figures that are here in group A are not closed. They're all open. This one even has a curve, so it can't be a polygon. You need straight lines to have a polygon. Same with this guy right here. But these in group B, these are all closed, but the only polygons would be this rectangle and this triangle, because this doesn't have straight lines and this doesn't have straight lines. And we know to be a polygon, you need to have straight lines. So the only polygons are this one and this one. And what kind of polygons? Well, it's a triangle and a quadrilateral. Okay. In your notebook, write down whether each figure is closed or open. Go ahead. All right, we should have said that this one is open, closed, open. And number 2 is a polygon. Nice job. And so, similarly to what we had said before, the only thing I want to bring up to you in this slide is that some kids on accident will think that circles are polygons. Circles are not polygons. Please press pause and write down why not in your notebook. All right, hopefully you said that the reason that a circle is not a polygon is because even though it is closed and even though it is a plane figure, meaning it's two-dimensional, it does not have straight lines. It's made up of curves, which means that it can't be a polygon. And so I cannot classify it as a polygon. Okay, so these are the examples of polygons that we were talking about here, and I just wanted to help you to remember which kind they are. So a triangle, you probably know triangle really well, but a triangle is a 3-sided polygon, and you need to specifically be able to explain that not only does it have 3 sides, it also has 3 angles. You can see them right here. And then, of course, the 3 sides are right here. And that makes a lot of sense because actually the prefix tri means 3. So you've seen this before in a couple of words you know, like tricycle or tripod. This picture down here of this red tricycle that a kid might have, you can see it has 3 wheels, which is where it got its name. Moving on to quadrilateral. Quadrilaterals, there are so many different types that we know, but they are 4-sided polygons. And not only do they have 4 sides, they also have 4 angles, of course. And that is because quad is a prefix that means 4. And you may have seen, quarter doesn't exactly have quad in it, but it does have the QUA blend in there, which a lot of times when you see that, whether it starts QUAR or QUAD, it means 4. So a quarter is a fourth of a dollar. You need 4 of them to create $1. Also, some kids might know what an actual quad is. Here's a picture of one down here. It is a 4-wheel or a 4-wheeler. Sometimes kids call them that. Kind of like a motorcycle, which has 2 wheels, but this one has 4, and they're really fun to drive around and be in open fields with. So that makes sense since there are the 4 wheels there. Pentagon. Some of you have heard of the Pentagon in Washington, D.C. It's a government building. This is a picture of it right here. You'll notice that the Pentagon has 5 sides to it, which makes sense because pent means 5. And pentagon figures have not only 5 sides, but they also have 5 angles. and those are pentagons. Hexagon I had a lot of trouble with coming up with an example for you because I'm not sure you know any words that have the word hex in it. But hex, the root hex actually does mean 6. And so hexagons are the shape that you've seen before that has 6 sides and 6 angles. So that is a special polygon as well. And then octagon finally, oct means 8, like an octopus. Octopus have 8 legs, of course. And so it makes sense that an octagon has 8 sides and 8 angles. So you are responsible for knowing these. If you want to press pause and write them down in your notebook so you don't forget them, you may. But we will be referring to these frequently. So these are also just examples of shapes, polygons that you've seen in real life before. Different signs when you're driving and things like that that are all special polygons with special names. So the only one up here that we haven't talked about yet is square, and that's because a square is a special kind of quadrilateral. So we're going to be getting into that next. All right, in your notebook, I want you to please press pause and answer these questions, true or false. Go ahead. Okay, so one thing you have to be careful about when you answer true and false questions, if the statement that is being made is not true all of the time, you have to say it's false. It has to always be true in order for it to be true. So an octagon has 8 sides and 8 angles. That is definitely always true. A hexagon has 7 vertices and 6 sides. So remember what vertices are. Those are the points that the 2 sides meet up at. So I might have to draw a hexagon to really be able to answer this question in the best way that I can. All right, here's a hexagon. Let me count the vertices. 1, 2, 3, 4, 5, 6. Yes, there are 6 vertices. So there's not 7. So already this is part false. And 6 sides, 1, 2, 3, 4, 5, 6. Yes, this part's true, this part's not, which means I have to say the statement's false. A square and a rectangle have 4 vertices and 4 angles each. Well, a square is a type of quadrilateral, and it definitely has 4 vertices and 4 angles. And a rectangle is another kind of polygon, which also has 4 vertices and 4 angles. So yes, that one's true. And all polygons have 4 sides? No way. We just saw a ton of examples of polygons that have 5 sides, 6 sides, 3 sides. So totally only the quadrilaterals have 4 sides. All right, so if you want to press pause and take a break, you can. We're going to get into another section right now about quadrilaterals. Otherwise, let's keep it moving. So there are 2 kinds of polygons that you can classify even more specifically than we already have. So again, close your eyes, picture the umbrella, the big umbrella of 2D figures. Within 2D figures, we have polygons, which are closed plane figures made up of line segments. And then within the polygon umbrella, we have, triangle, quadrilateral, pentagon, octagon, all of those. Quadrilaterals have their own umbrella. There's a ton of them. And then triangles have their own umbrella. So we're going to look at both. First, we're going to explore quadrilaterals. So quadrilaterals have to have 4 sides and 4 angles no matter what. So all of these pictures that you see up here, picture A, B, C, D, E, F, and G, they all have 4 sides and 4 angles for sure, if you were to count them up. However, even though I see that, they still all look really different. So there's got to be another way to classify them and talk about them. Here are the things that we know for sure about quadrilaterals and their properties. Some quadrilaterals are going to have special names, and we will get there. But the way we figured out is we look at their pairs of sides that are parallel. We look at their pairs of sides that have equal length. And we also look for right angles. So what does that mean? First of all, let's remember what parallel and perpendicular means. Parallel lines are lines that go on and on forever in both directions, and they will never, ever touch each other, ever, no matter what. So if I draw a line here and I draw a line here, they eventually intersect, meaning there's a point that they both touch together. However, if I draw a line like this, and then I draw another line like this, Those lines will never touch each other, even if I keep drawing forever and ever for the whole rest of my life. Those are called parallel lines. Perpendicular lines are different in that they definitely do intersect, but they have a special intersection. So those two lines I drew earlier, they do intersect here, but the reason that perpendicular lines are special and I always remember because perpendicular kind of sounds like the word peculiar, like strange or different or weird. And so they are weird intersecting lines in that when they cross each other and they intersect at exactly a 90-degree angle. Sometimes you'll see this box, it's used to notate a right angle. Right angles are always 90 degrees. So if I measured that with a protractor, like you practiced with Miss Johnson, this angle right here is 90 degrees. And the reason the 90-degree angle is so special is because 2 of them make 180 degrees, which is a straight line, and 4 of them make 360 degrees, which is a full circle. So right angles are a fourth of a circle when you think about it, or a quarter of a circle. And so when we use benchmarks in math, we think a lot about wholes, halves, and quarters, and so it makes a lot of sense that we think about right angles as being important in math. So then going back here, when we're thinking about this, we are going to look at special quadrilaterals based on parallel lines, based on right angles that we see because we see perpendicular lines, and also based on side lengths. So I want you to keep track of these in your notes. I should see all of them. Make a page that says quadrilaterals and write down our first one, which is a square. Squares have a lot of properties. When we're talking about pairs of parallel sides, this is what I mean. I mean, here is a line right here, line segment. Here's another line segment right here, and those 2 line segments right there are parallel. That means that so far I see one set of parallel lines. But if I keep looking at the figure, I notice that this segment and this segment are also parallel to each other, which means that squares have 2 sets of parallel lines. That's important because not all quadrilaterals do have parallel lines. If you notice, in the beginning we saw a quadrilateral that looked like this. 1, 2, 3, 4 sides. And oh my gosh, there's no parallel lines in that thing. So there are definitely differences related to parallel lines that we see for sure. Parallel lines, when you have 2 sets like this, they force a right angle. So because they're parallel and they're going straight up and down like that, then you have to have a right angle where they meet because they make a perfect letter T or a perfect cross when they meet each other. And so they make a 90-degree angle like we saw with our perpendicular lines. So squares also always have 4 right angles for sure. And the other thing that's really special about a square is that all 4 of the sides are of equal length. We mark equal length, or what we call congruence in math. We mark them with little ticks. I call these ticks. So these red ticks suggest that all 4 of these sides are the same exact length. They are all 3 units long, which is what makes it a square. Okay, a rectangle, I kind of think of it like a stretched out square. So, but because it's stretched out, that means it loses one of the properties. It has all the same properties of a square, except for that all the sides are not congruent. They're not all matching or the same. So I do still have 2 sets of parallel lines. Here's 1, here's 2. I do still have 4 right angles, but I no longer have all equal sides. But what I do have is opposite sides are the same. So this side and this side are equal to each other, and this long side and this long side are equal to each other. So just like in our bar models, I mark it with different ticks. So like, since this one's equal to this one, I use 1 line, and then since this one's equal to this one, I use 2 lines to mark it. Kind of like what we do in the bar models with our dots. Parallelograms are interesting because the only trait that you can be sure of in a parallelogram is that they have 2 sets of parallel sides. So they're going to have, just like the square and the rectangle, this set and also this set. And that's it. There's nothing else special about them that you can use to identify them, aside from the fact that, of course, they have 4 angles, but all quadrilaterals have 4 angles, so that's not really that special. Okay, a rhombus. I sort of think of a rhombus as like a tilted square. So a rhombus The only thing that it doesn't have this square has is right angles, because the way that the lines cross, they don't force the right angle. So I still do have this pair of parallel sides and this pair of parallel sides, but they're not straight up and down like a T the way they were before. So I do have all sides the same or congruent, but I don't have right angles. That's the only thing missing from a rhombus, is the right angles. And finally, a trapezoid. So trapezoids are special because they only have one set of parallel lines. And then they do not have parallel lines on the other side, because as you can see, if I were to keep extending this line and I keep extending this line, they will eventually intersect, which means they're not parallel. The blue lines, however, if I extend them in both directions, they will never ever touch each other. So trapezoids have one pair of parallel sides, but they do, of course, still have four sides and angles because they are a quadrilateral. So how can we classify them? This is pretty cool. So what you're going to see is that all of these things are quadrilaterals right here. There's my trapezoid, my rhombus, my square, and my rectangle. And they're all four-sided, and they're all quadrilaterals, right? I could say, since I know a parallelogram means that I just need to have two pairs of parallel lines, like I see here, then that technically means that a rhombus is also a parallelogram, a rectangle is a parallelogram, and a square is a parallelogram, technically. So then also I could say, within the parallelograms, there are two figures that have congruent sides, or sides that are all the same. Squares have all the same side lengths, and rhombus have all the same side lengths. So they are classified together. And then also, I could do the same with angles, because remember we think about sides and angles. Rectangles have all right angles, or all congruent angles, and squares have all congruent angles too. So because of that, these are all going to be congruent as well. And then finally, that means that the most specific shape you can possibly ever have is a square. Squares have all the properties. They have congruent sides, they have congruent angles, and they also have your opposite sides that are parallel. Okay, I think that you need a break. There's a second video that you're going to watch that goes with this. But for now, I want you to stop here, check your notebook, and study your shapes. Go ahead.